Hey guys, welcome to Food for Thought, where today we'll be talking about physics, or more specifically, kinematics, which is a description of how things move. So before describing how anything moves, what we need to do first is establish a reference frame to describe motion in. And the reason we need a reference frame is because many of these quantities will be that we're measuring in physics will change based on what reference frame you're describing them in. And some of these quantities will be what we call vector quantities. Vectors are any quantities that have both a magnitude or a size and a direction. So the magnitude is going to describe how big this motion, this value is, rather, and the direction is just going to be like what direction is this value working in. And these are going to be opposed to scalars, which are another type of quantity we'll sometimes work with, and scalars only have a magnitude. So the reason vectors are important is that in order to properly describe motion, we need a direction. So say I tell you I'm moving at, say, 5 meters per second in whatever. I'm moving at 5 meters per second. Well, you might wonder, well, what direction are you moving in? Because just knowing this 5 meters per second doesn't fully describe my motion. I would need to tell you something like I'm moving 5 meters per second west or something. I would need to give you a direction in order to fully describe this motion. And so, in order to create this direction, what we need to do first is establish a coordinate system. And since we're mostly going to be working in one dimension right now, this coordinate system is just going to be a line going from left to right, with 0 somewhere near the center, say here. And by convention, we're going to define the right direction as positive and the leftward direction as negative. And this just means that any time we move to the right, that'll be positive motion. Anytime we move to the left, that'll be negative motion. And this makes the math a lot easier. So here we have some examples of how different reference frames can affect different measurements. So let's say that this car here is moving at 20 meters per second in the positive direction. So positive 20 meters per second, right? And this car is always moving at 20 meters per second. And let's say you're this red person and you want to measure how fast this car is moving. Well, in the first scenario, let's say that you as this red person, let's say you're moving at 0 meters per second relative to the ground, that is. Everything here can be relative to the ground. If you're moving at 0 meters per second and you take out your physics measuring equipment or whatever and you measure how fast this car is moving, then you will indeed get 20 meters per second. Right? You just measure the car, it's moving at 20 meters per second. You see that, great. But instead, let's say, instead of moving at 0 meters per second, let's say that you're actually walking leftwards in the negative direction, rather, at -1 meters per second. So, if you're moving at -1 meters per second, and this car is still moving at positive 20 meters per second relative to the ground, then if you take out this measuring equipment and measure the car's speed, or velocity rather, you'll see that it's moving at actually positive 21 meters per second. Because the car is moving this way at 20 meters per second. And then there's also the added speed or velocity of you moving at 1 meter per second that sort of adds to the observed velocity of the car. So you get a total of 21. So this extra bit is going to be a 1 meter per second. So we add these together and we get an observed 21 meters per second. I'm going to put a plus here, make sure to specify that this is in the positive direction. And now finally, let's say that you're actually in the car, right? And there's some other person standing out here. Well, if you're in the car, then your speed relative to the ground is positive 20 meters per second. Now, if you're in the car, then the car is actually at rest relative to you. Your velocities are both 20 meters per second. So that means that your observed car velocity will actually be 0 meters per second. Actually, the positive here isn't necessary, it's just 0. And let's say that this person is the same as this person back here. He's moving at -1 meters per second in relative to the ground. Well, now that you're moving at 20 meters per second, then that means that this person will be observed to be moving at actually -21 meters per second. So basically the exact opposite of what you saw here. Because now you're in the car, and as you're moving in the positive direction, it'll look like this person here is walking in the negative direction, is moving in the negative direction very quickly at 21 meters per second. So that was just an example to show how different reference frames can affect your measurements of the motion of different objects. Now that we understand what a reference frame is, we can start to better define these different values we can measure, like velocity and acceleration. So that's what we'll be doing next time, defining these kinematic quantities that we can measure in a reference frame.